When we think about the future of AI, it's pretty easy to picture this one giant, all-knowing superbrain, right? But what if that's not the answer? What if the real key to unlocking AI's potential isn't about building one massive system, but actually about teaching AIs how to work together as a team? Let's dive into why teamwork might just be the secret ingredient for AI scalability.
So, this really gets to the heart of what we're exploring today. To tackle the world's biggest, messiest problems, do we want the single, monolithic brain on the left, or do we want the interconnected network of specialist agents on the right? Is bigger always better, or is smarter teamwork the real way forward? The thing is, that lone genius model, well, it has some pretty serious problems. For one, trying to build a single entity to solve every problem is just incredibly expensive. It's also not very flexible, and if one little part of it fails, the whole thing could just grind to a halt. It really struggles with those complex, layered problems that need different kinds of expertise. And that brings us to the most important word for this whole conversation: scalability. And look, it's not just about handling more data. Real scalability is about an AI system's ability to adapt, to grow, and to take on way more complex challenges without falling apart or becoming super inefficient. That's the real goal here.
So, what's the solution? Well, it's this really elegant idea called multi-agent systems, or MAS for short. Instead of one giant AI, just imagine a team of AIs. It's a system made up of multiple smart agents that can talk to each other, coordinate, and collaborate to get something done. Kind of like a dream team of human experts.
And the advantages of this team approach are just huge. I mean, these systems are super flexible and scalable. You can add or remove agents whenever you need to. They're way more robust because if one agent goes down, the others can just pick up the slack. They can even organize themselves to figure out who does what, and they can do it all in real time. Okay, but how does an AI team actually, act like a team? It's not as simple as just putting them all in the same digital room. They need a playbook, a set of rules for how they're going to collaborate. So let's check out the different styles of teamwork they can use.
So yeah, AI teamwork isn't a one-size-fits-all kind of deal. This breaks it down into three main modes. First up, you've got pure cooperation. That's where everyone is working towards the exact same goal. Then there's competition, where agents actually have conflicting goals, which surprisingly can make the whole system stronger. And finally, you get this really cool blend called co-petition.
Here is a perfect example of cooperation in action. Let's say you want to write a big academic paper. You could have a researcher agent digging up information, a translator agent handling different languages, and a verifier agent checking all the facts. They all have their own specific job, but they're all working together for one single goal: creating a top-notch paper. Now let's look at competition. This is a brilliant way to understand it: a courtroom simulation. You've got a prosecutor agent and a defendant agent. Their goals are in total conflict, right? They're debating to win the case. But that adversarial process, that fight, actually forces both of them to come up with stronger, better, more robust arguments. And here's that hybrid, co-petition. Think about negotiating something like a new public policy. You might have several agents, each representing a different interest group. They have to cooperate to agree on the basic rules, but they're going to compete to make sure their specific priorities get into the final deal. It's this delicate dance of compromise and self-interest. So, beyond just the style, there are also different strategies. The first one is rule-based. It's pretty straightforward. The agents follow a very strict, predefined set of rules. On the plus side, it's efficient and predictable. But the big downside? It's not very adaptable. If something unexpected happens, the system can't really think on its feet, which makes it tough to scale for really complicated jobs.
A much more common strategy is role-based. This is just like a human team, where each agent gets a specific job based on what it's good at. This is amazing for organizing things and using specialists. The only potential catch? It can be a little rigid, and the whole thing lives or dies based on how well those agents are communicating with each other.
All right, so we've got collaboration styles and we've got strategies. But there's one more really critical piece to this puzzle: the organization. How the agents are connected and how they talk to each other is absolutely key. So let's take a look at the different kinds of org charts you can have for an AI team. First up is the centralized or star structure. This is probably the simplest design you can imagine. You have one central agent, the hub, and all the other agents have to communicate through it. That central agent is basically the manager, coordinating everything. Now, the pros are pretty obvious. It's simple to build and it's easy to manage. But the con is a massive risk for scalability. That central hub is a single point of failure. If that hub goes down, the entire system completely collapses. It's just not a very resilient way to scale things up.
So to fix that exact problem, we have the decentralized structure. Here, there's no central boss. Agents can talk directly to each other in this big, distributed network. Information just flows freely between any two agents that need to connect.
And this is where you get a huge leap forward in both scalability and robustness. There's no single point of failure, so the system can keep on trucking even if a few agents drop out. What's the trade-off? Well, it can create a lot of communication chatter, which can sometimes slow things down if it's not managed really well.
And finally, we've got a model that kind of blends the two, the hierarchical structure. This looks exactly like a corporate org chart. You have agents organized in layers with different levels of authority. A manager agent might coordinate a small team of specialists, who then delegate tasks down to worker agents.
This structure is fantastic at handing out tasks efficiently, and it avoids that single bottleneck you get in a purely centralized system. But it is definitely more complex to design. And while it's tougher than a star structure, if a key manager agent fails, it can still cause major problems for everyone downstream. The real key here is choosing the right structure for the right task.
Okay, so that's a lot of theory. But is anyone actually using this stuff today? Oh, absolutely. Let's shift gears and look at how these AI teams are already out there in the real world, solving some pretty fascinating problems.
The applications are just all over the place. We've got agent teams like ChatDev that basically act like a virtual software company to write and test code. There are social simulations like Culture Park, where agents with different cultural backgrounds interact to see what happens. They're being used in customer service and even to create high-quality training data for other AIs to learn from.
This diagram from OpenAI is just a fantastic, crystal clear example. It shows a customer service swarm. So when you send in a request, it first hits a triage agent. That agent's only job is to figure out what you want. Do you want to buy something? Okay, you go to the sales agent. Do you want a refund? Off to the refund agent you go. It's a simple, scalable, and super efficient way to divide up the work.
Of course, this is all still evolving, and there are some big challenges still ahead. For instance, how do you even measure the performance of a whole team and not just one agent? How do you make sure the system is safe and stop bad information or even malicious behavior from spreading? And what on earth do you do about the overconfidence problem, where an agent is absolutely sure it's right, even when it's totally wrong?
These are the exact questions that researchers are working on right now. But as we've seen, the big shift from a single AI mind to a whole collaborative society of minds is already happening. It's a more scalable, more robust, and way more flexible way to build AI. And that leaves us with one final, really exciting question. What massive, world-changing problems could these AI teams solve next?